and welcome to the launch broadcast for Rocket Lab's 20th Electron mission, Running Out of Toes. Electron is fueled and ready for liftoff from Rocket Lab's Pad A at Launch Complex 1 in Mahia on New Zealand's east coast. My name is Muriel Baker and I'm here at Rocket Lab's Mission Control Centre in Auckland, New Zealand, where I'll be taking you through the launch of this dedicated mission for Earth monitoring company Black Sky. It is close to 10 p.m. on Saturday, May 15th. This mission has a window of approximately 2 hours, and we're expecting to launch right at the top of that window at 10:08 p.m. New Zealand local time. Our launch operations team are not working any issues, and with greens across the board, we're well set for an on-time launch. Running Out of Toes is a significant mission for the team here at Rocket Lab as our next major recovery test. For only the second time ever, we will attempt to bring Electron's first stage back to Earth under a parachute and splash it down gently in the ocean as part of our efforts to make Electron the world's first reusable small launch vehicle. Our recovery team is currently stationed in the Pacific Ocean, waiting for Electron's splashdown so they can retrieve it and bring it back to our factory for inspection. However, weather conditions have deteriorated significantly in the splashdown zone, which means we have limited live communications with the recovery team. Visibility at sea is also greatly reduced, so it may take some time to provide confirmation of a successful splashdown, and we may not get this during the webcast. Nonetheless, conditions are optimal for launch, so we are proceeding with the count. Today's recovery attempt will follow a pretty similar process to our first recovery attempt 6 months ago on our return to sender mission in November. But here's what's new for this mission. We've strengthened Electron's thermal protection system with an upgraded heat shield to help protect the booster's Rutherford engines. We've also refined our retrieval logistics and introduced the Ocean Recovery and Capture Apparatus, otherwise known as ORCA, to our recovery vessel. This hydraulic cradle is essentially a recovery-optimized strongback to help safely bring Electron aboard. But maybe most excitingly for this mission is the fact that we'll be flying previously used components for the very first time. Electron returned in such good condition during the return to sender mission that we're reusing its propellant press system on this one. Now, with the recovery team out at sea patiently waiting for liftoff, let's take a look at what's involved in the recovery process. At approximately 2.5 minutes after liftoff, at around an altitude of 80 kilometers, Electron's first and second stages will separate. Electron's second stage will continue this mission's journey to orbit before the kick stage separates to deploy the satellites. Now, this is part of a standard mission profile, but next is where it gets interesting for recovery. During its descent, Electron will reach around 8 times the speed of sound, and the air around Electron will heat up to 2,400 degrees Celsius, generating an extremely hot plasma that creates a red-orange glow around the re-entering stage. To help Electron survive this brutal experience, a reaction control system on the first stage will orient the stage 180 degrees to place it on an ideal angle for atmospheric re-entry. From hypersonic speed, we decelerate the first stage to below Mach 2 before a drogue parachute is released to increase the vehicle's drag and help stabilize it. In the final kilometers of re-entry, a main parachute will be deployed to further slow the stage and enable a controlled splashdown. Our team on the recovery vessel will then rendezvous with the stage and bring it on board the ship with ORCA before transporting it back to our production complex for inspection. For tonight's recovery attempt, we'll have cameras on board Electron's first stage feeding us live footage, and we'll stick to those views as long as we can, but seeing as it's a night launch, our views will be limited by the lack of sunlight. We're also expecting to lose the camera view during a telemetry switch between our ground tracking stations, and due to poor weather in the splashdown area, we may not get real-time comms from the recovery team during the webcast. We'll listen out for the calls, of course, but if we don't get them live, we'll share updates on our social media channels to keep you posted on Electron's return to Earth. We're approaching T-minus 12 minutes in the count, and soon our operators will be run through the go, no-go poll by this mission's launch director, Sean DeMello. Let's listen in to Mission Control and check how we're tracking for launch.
All stations, LD and mission, proceeding with a go-no-go sequence at this time. Looking for your status to proceed for launch. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCon.
VCon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
Mission management.
MM is go.
Recovery.
Recovery is go.
LD sub.
LD sub go.
Executive.
Executive is go.
Go-no-go sequence complete. We are at 11 minutes, 12 seconds and counting. We're go for terminal count start at T-minus 10 minutes. From this point on, the 3-word hold procedure is in effect.
There you have it. That's confirmation from Mission Control that all systems are go and will be proceeding with the remainder of the count. Liftoff remains scheduled for 10:08 p.m. New Zealand local time or 10:08 a.m. UTC. Now to this launch's primary mission objective. Running out of tows is our third mission for 2021 and the first of several dedicated launches this year for Black Sky, which provides geospatial intelligence and global monitoring services through their low Earth orbit constellation. Electron will be launching 2 of these satellites at a 50-degree inclination from Launch Complex 1 and deploying them to a 430-kilometre orbit. Once in space, these Gen 2 satellites will mean Black Sky can better deliver insights to decision makers, responding to disasters or tracking economic activity across the globe. Here's more from Black Sky. They go up so fast, rideshare mission in March. Tonight's mission is part of an overall deal to deploy 9 Black Sky satellites across 5 Electron missions this year that delivers them the rapid launch capability they need to expand their constellation quickly. For the team here at Rocket Lab, this mission also marks a couple of fantastic achievements, because tonight's launch will be the 20th time Electron leaves the pad, powered by our 200th Rutherford engine. It's incredible to think that we've built, tested and fired 200 of our unique 3D printed electric pump-fed engines. Rutherford is the world's first 3D printed orbital rocket engine, a unique design that went against the grain of traditional rocket propulsion systems when we first introduced the idea. Rutherford also made space travel electric by replacing the traditional gas generator cycle with electric pumps, powered by lithium polymer batteries. This mission is one for the history books, so we sat down with some of the team who helped make it happen to talk through their experiences of our first 20 Electron launches.
What we have here is just a completely, defiant group of people who really want to execute and see things succeed.
It never gets old, whether it's the first flight to orbit or the 20th, whether it's our first customer or our 200th, we're learning something every single time.
I mean, I'd been here for 5 months. We didn't know if it was going to work.
It's mainly getting the customer's payload into space. It's game time.
Launch day is Space Super Bowl, right?
I don't even remember breathing, but it was worth it. It's a feeling you just can't describe. You just have to really be there.
I'm much more interested in the payload these days. So for the first few flights, it was all about the rocket. Whereas now, I get to know a little bit more about who we're launching.
Launch day is way harder than I thought it was going to be. I thought by the time you get to 20 launches or some number, it would just be like, making coffee. Everybody's just so invested in each launch that there's always so much energy around each launch.
Hearing that our first light satellites come alive and things like that it's a totally different feeling than just we've launched this rocket and that's been awesome.
20 missions is a huge achievement, and it's been incredibly exciting, but I'm even more pumped for the next 20.
So I'm super stoked about recovery from the quality engineering perspective.
I like the fact that you get to launch the next. It means that you've done your job right.
Fundamentally, we must have a really good design. The fact that we can launch this many rockets, Electron's a good product.
Rocket Lab's secret sauce is its engineers' dedication to rapid development.
We would not have been successful had it been a different group of people.
Oh, I think I'll be in front of the 20 flights.
Congratulations to every single Rocket Labber who got us to the pad today and helped us reach these milestones. A check-in on how we're tracking to liftoff. The team are working no issues with the launch vehicle. Electron's payload remains healthy and the weather is looking clear for an on-time launch. We're approaching a critical juncture in the lead up to launch now, the switch to the countdown auto sequence. In T-minus 2 minutes, the autonomous flight computers on Electron will take over the count. At around T-minus 1 minute 30 seconds, we should hear the call that LOX loading is complete on Electron. And then shortly after that, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch, followed by the 10-second countdown to liftoff with engine ignition at T-minus 3 seconds. Let's hand over now to Mission Control and listen in for those calls.
We are go for auto sequence start at T-minus 2 minutes.
HV blips nominal.
Confirm LDs go for launch.
Hold.
Got to hold. Recycling T-minus 12 minutes. All stations stand by for recycle to T-minus 12 minutes. GC confirm a launch inhibit mode.
Still in prime mode.
Confirmed we were inhibit at this time.
So you heard it there from Mission Control in Auckland. Right now, Electron has entered a hold while our operators work on establishing a new T0 time. We'll continue to broadcast while we wait for an update from the team. In the event of an extended hold, we'll provide an update via our social media channels. Thanks for watching. We'll be back with you soon.
Proceed with stage general board checks 63.
Copy, understood.
All stations will be setting the clock for T-minus 12 minutes. We'll be holding at that time to resolve the hold called by GNC.
Vehicle is unacceptable. Avionics terminal abort check.
All stations, LD admission, we're currently cycling back to T-minus 12 minutes. We have a hold called for winds aloft or upper right winds. We'll circle back once we've had an opportunity to review the data.
LD, GC on mission, launch vehicle secure.
If you're just joining us, we have entered a hold due to upper level winds and have recycled the clock to T-minus 12 minutes. We'll stay on the live view of Electron on the pad while the team assesses those wind levels, and we'll come back to you with a new T0 as soon as it's confirmed.
stage LD mission.
LD stage.
Configure OFVs for lock stopper.
Copy.
PLS proceed with lock stop after this time.
Roger, lock stop up in work.
A quick update from Mission Control here. As you can see, we're currently in a hold due to upper level winds. Stick with us as we establish a new T0 time. We'll let you know as soon as that happens. But today's window remains open until 12:05 a.m. New Zealand time or 12:05 UTC.
On all stations, LD on mission, we're currently holding the clock at T-minus 12 minutes while the GNC team work through further verification of upper air winds and running some worst case data. Expected time to pick up the count is no earlier than 11:11:39 UTC. That's for target T0. I'll report back in about 10 to 15 minutes when we hear back from GNC.
Hello again. As you can see at the bottom right of your screen, we are currently holding at T-minus 12 minutes. The team is assessing upper level winds to determine a new T0 for today's liftoff. All other systems remain go though for launch, so it's just a waiting game for those upper level winds. We'll update you as soon as we have a new T0. Another quick update from Rocket Lab Mission Control. We are still sitting tight on the pad, waiting for upper level winds to fall within bounds for launch. The clock is currently held at T-minus 12 minutes, so while we wait for that new T0, let's take a look back at our first recovery mission back in November last year.
Congratulations to the recovery team. That team has pulled off a miracle with re-entry of Electron in the first ever attempt. So in the return to sender mission, we set out to achieve a number of things, and all of those things increase in complexity and risk. The first thing was to reorientate the stage and get it in the right angle of attack. We've done that a couple of times before, so that was obviously very successful. And the next big thing was to start deploying the parachute systems. And we ticked off each one of those milestones one by one in a very successful manner, and then ultimately splashed down the stage at a really low velocity into the ocean in wonderful condition. So that was kind of like the giant tip. And in fact, there's even components on that stage that we intend to refly in an upcoming mission. So the thing I'm most excited about reusable Electron is two things. One, we can offer many more flight opportunities because we don't have to build so many rockets. And right now, we're pushing one Electron rocket off the line every 30 days. If we can reuse Electron, then we can create a lot more flight opportunities. Equally well, if we can reuse Electron and get them back in the condition that we're hoping now, it completely changes the economics of the small launch industry, which I think for our customers is really exciting. Electron is a reusable rocket. It's a great milestone, and I guess something a few years ago that I didn't even think was possible, so that makes it even more sweet.
Thank you for tuning in to today's launch broadcast. As you can see, the clock has resumed and we are currently at T-minus 17 minutes and counting. Electron might be the rocket on the pad today, but recently we announced plans to build its much larger sibling, Neutron. While we wait for a new T0, let's take a look back at that announcement.
When we say we're going to do something at Rocket Lab, we do it. Not just once, but over and over again. The Electron rocket defined a number of industry firsts. First carbon fibre rocket to orbit, in fact. Somebody told me once that was going to be impossible. And it's reusable. But then there's the engines. The Rutherford rocket engine, the very first 3D printed rocket engine ever to go into orbit. And in fact also the very first electric pump cycle rocket engine ever produced. And of course we didn't stop at rockets. We started building satellites too. Satellites to go to low Earth orbit, satellites to the Moon, to Mars and Venus and beyond. And there's a lot more to come. But first, I've got to take care of some business here. There's a lot of things at Rocket Lab that we said we were going to do that we've done. And a few things at Rocket Lab that we said we would never do, which we have also done. So I really think with this project, it's about time I finally ate the hat.
We're approaching T-minus 12 minutes in the count, and soon our operators will conduct another go-no-go poll after the hold. Let's listen into Mission Control and check how we're tracking for our second attempt of the day.
All stations LD on mission cord, proceeding with the go-no-go poll for launch. Stage.
Status go.
Avionics.
Let's go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
Met is go.
Mission management.
Mission management's go.
Recovery.
Recovery is go.
LD sub.
LD sub go.
Executive.
Exec is go.
Go no go sequence complete. We're at T minus 11 minutes, 21 seconds and counting. We'll go for terminal count to T minus 10 minutes. From this point on, the 3-word hold procedure is in effect. GC, LD mission.
LD GC.
Proceed with sequence 50, pad terminal checks.
Copy proceeding with sequence 50, pad terminal check.
Avionics LD mission.
Go ahead.
Proceed with avionics terminal checks, sequence 51.
Proceeding with sequence 51.
LD GC on mission cord.
Go.
Stage 1 igniter pressures verified, hydraulic pressures verified, S1 pre-valve open, pad terminal checks complete.
Copy that. Stage LD mission.
LD stage.
Proceed with sequence 52, stage terminal checks.
Copy.
GC LD mission.
LD GC.
Proceed with pad ready for launch, sequence 53.
Copy proceeding with sequence 53.
Expander switch to high power for flight. Stage 1 and Stage 2 high voltage batteries ready for flight.
All engine blips are nominal, all engines are ready, the stage terminal checks are complete.
Copy that stage. Avionics LD mission.
Go ahead.
Proceed with sequence 54, AFDS enable for flight.
Proceeding sequence 54. AFTS is green and enabled flight.
Copy.
Hold on mechanisms armed, strong back retractor for flight. LDGC on mission.
Go.
BCS disabled, pad auto sequence is armed, pad ready for launch.
Copy. Recovery LD mission.
Go ahead.
Proceed. Confirm recovery as goes a green.
Affirmative.
And monitor them from the airborne.
Affirmative.
Avionics LD mission.
Go ahead.
Proceed with sequence 55. Enable recovery systems for flight.
Proceeding with sequence 55.
We are at T-minus 4 minutes and 42 seconds and counting. The strong back has been retracted for flight and those upper level winds are currently playing ball. From here on out, we'll listen into mission control as they proceed to T0.
All stations and missions, LD. From this point on, there should be no red flags in the critical LCCs.
HVB reports.
Copy that, avionics. VCON LD mission.
LD Beacon.
Confirm flight computer as goes a green.
All as goes green.
Lock auto sequence and confirm.
Auto sequence locked.
All stations ready to go for auto sequence start at T-minus 2 minutes. At this time, LDs go for launch.
HVBs are on internal power. Confirm all stage power is disabled. Vehicle is on internal power.
Box load complete. System into recirculation. Anti-rise ring disabled. High flow engine purge enabled.
Stage 1 and Stage 2 tank suppressed.
Deluge activated.
T-minus 20 and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2.
At T+30
Stage 1
seconds into
propulsion
the
is
mission,
nominal.
Electron is well on its way to space after its 20th liftoff from the pad at Rocket Lab Launch Complex 1. We had a great view from the tracking cameras of the
Entered
power
stage
of
one
those
burnout
Rutherford
detect mode.
engines, with Electron clearing past 700, it's clearing well on its way to space right now. And very soon Electron will approach max Q, or maximum aerodynamic pressure. And this is the moment when the forces against the launch vehicle are at their peak during ascent. So let's listen in for the
Vehicle is
call that
supersonic.
Electron has cleared that
Good
gate.
ship run 1.
Approaching max Q.
HVB discharge nominal.
Max Q cleared.
Trim ship run 2.
There's the call out. Electron has successfully passed through max Q, with propulsion continuing nominally. In about a minute, we'll be coming up to 3 events that happen back to back during flight. First is
Guidance
main
is
engine
nominal.
cutoff, or MECO. This is when the 9 Rutherford engines on Electron's booster throttle down before shutting off completely to slow the rocket down before the second event. That's when the first stage separates from the rest of Electron as it continues with the third event, ignition of the sole Rutherford engine that powers Electron and the satellites to orbit. With that stage separation, Electron's booster begins its journey back to Earth, and so will begin our second Electron recovery attempt. We'll hopefully have a live camera feed on that first stage to watch that descent take place. But before we get ahead of ourselves, let's wait
15
for the
seconds
call out
to
for
go.
those 3 events.
Stage 1 propulsion is nominal. And MECO confirmed.
Successful separation.
Stage ignition.
Recovery.
At analyst recovery, proceed with sequence 59, stage 1 recovery operations.
Computing landing zone.
As you've seen, we've had a successful MECO and stage No, there's been no ignition, sorry, but on your screen, we'll keep that view and see what we can come back to you with soon. Okay, so it looks like we've had a loss of telemetry. We'll come back to you with more information as soon as we have it. An update from Rocket Lab Mission Control. We are experiencing a telemetry issue with today's mission and therefore do not have live views of the vehicle to bring you at this time. So we're going to end today's webcast and bring you updates via our social media channels. Thank you for tuning in to today's mission. We'll see you back here soon.